So you may have been reading a lot of large language models lately, and it seems to be a very dynamic and hot topic for the past 2 years. And once the first chatbots were released on September 2021, ChatGPT, then everything has started to multiplicate and everything changes so fast. And now there is a wide slew of different large language models, and large language models are not only applied or being applied in the traditional chatbots, but also are being used for, like, for example, discover new proteins, new materials, and also is being applied like in genomics and many other in other fields. And then of course the generative AI uh, not only was restricted now to texts generation, but also for image generation, videos generation, and also audio generation. So generative AI has expanded in the last less than 2 years into different fields, and of course these models. I'm gonna use the slide presentation. And these models, of course, have generated a lot of concerns in the population. For example, people feeling that um, probably they will lose their jobs to AI, but actually they're not going to lose their jobs. The jobs will be changing with AI, and also it may eventually some jobs disappear, but no one is taking anyone's job. Okay, so this is part of one of the trainings we did uh, a year ago on GPT 101, and I addressed the topic of large language models, and this is an image how the large language models have been evolving, well, since the past 5 years, and then you will see that basically right now the scenario is that the large companies like Google, Meta, and AI are defining what is the trends of the technologies. And also there are some other companies like Anthropic, which owns Claude, and Claude is the Anthropic is just a group of people that um, went out from OpenAI. And also you will see that, for example, Microsoft has invested some funds on ChatGPT from OpenAI to have their own now Microsoft Copilot included in all their products. And you will see that although Google has developed Bard and now has the version called Gemini, also has invested some funds into Anthropic. So right now, the main four large language models that dominate the market is OpenAI ChatGPT 4, and we have Gemini from Google, we have Claude 3 from Anthropic, and also we have Llama 3 from Meta. And Llama is available as open source. Of course, the training model, for example, I will see later how much does it cost and how many resources are needed to train a model. So Meta is just giving away a trained model, and they had the resources to train a new model. Okay. Okay, so that's more or less the evolutionary tree for LLMs. And then, of course, you will find that once you can take any pre-trained model and then focus on a different training on particular topic. and you will find that there are some large language models dedicated to a specific task, like in the legal world or in the health sciences, etc. Okay, this is a leaderboard from this site, LMCs, and you can see that there are many versions of the same model, and the versions differ in the size of the parameters they were used to train it. For example, this number 6 is Meta Llama 3, was constructed with 70 billion parameters, and then there will be a smaller version with probably 7 billion parameters. You have the GPT-4, you have the Claude 3, you have the Bard or Gemini Pro, and then, for example, for Cloud 3, you have different versions, the Opus and the Sonnet, and this is a ranking system, ELO, to rank the performance of different large language models when they're doing different tasks. So there's a leaderboard that keeps track of all these large language models, and you can see some of them are proprietary, and some of them are open to the community. Even like Command R Plus is Creative Commons. And also, it doesn't appear here, but there's a small model by Microsoft called Phi 3, something like that. It's very small, so you can try to implement it in a small device. And also Llama from Meta, you can download Llama into your computer, Windows or Mac, and you can run it on your machine, or you can run it on a server. Okay, so how do large language models function? So for example, when we're using Google search and you type any set of words, and Google will try to fill out the next word. So basically, Google is doing this based on their cache memory. Maybe you have typed this, or maybe someone else has typed that. And then it was trying to guess what's the next word. So large language models function similarly. So they are trained, for example, with English text. That was before. Now you will see that large language models have been trained with multi-language. And also you can find, also you can interact with the large language models in any language. So this is how they train it. So they give a phrase to the model, like the dog eats the apples, and each word is stored in a vector database, and every word is just a number. And so space dog has 3290 number. Space eats, it's 25,365, etc. But if you train it in a different language, like El perro come las manzanas in Spanish, then and you try to apply the same vector database, then the words do not apply correctly. So you have to train it specifically for a specific language. This is a map how the generative pre-trained transformers are trained. And this involves several steps. So we have the pre-training stage, and then after you pre-train it, like you take a large amount of text from the internet, and then you'd start training with a neural network or transformer what will be the next word, and you iterate it until you get some base model out. And then in this part, the pre-training, for example, for GPT or Llama or Palm, they use thousands of GPUs, and it took months of training. And then once you have the base model, then you go into the next stage, which is going to be supervised fine tuning. So you're asking questions to the model, and you're validating the responses. and this process is written by humans, and they assess the output from the model. They try to like give thumbs up or thumbs down to the response. So they are at the end they will have a super fine-tuned model, and then it goes to the next stage, which is the reward modeling. Again, you have hundreds of thousands of questions written by contractors, and they're trying to see what is the output. And once you have the reward modeling, you go to the next stage, which is the reinforcement learning. Again, you will have hundreds of thousands, probably, of prompts written by people, and they're trying to assess the response from the models. And then you end up with this, what they call the reinforced learning model. And that's, for example, in this case, um, they required hundreds of GPUs, days of training, and then they deploy the model. So this process takes months. You don't have, like in other types of software, like a release every week or every 3 weeks. The release of the new versions of the large language models are only probably once a year or maybe twice a year, but it's not something that you can do on a monthly basis. Okay. Any question, just stop and ask. Okay. So, so it's important to know that these models were trained with your data, and if your data is erroneous or inaccurate or homogeneous or unfiltered, unbalanced, etc., then the output can be biased, can be non-generalizable, can be uncreative, unreliable, etc., unethical. So you will hear a lot of talks about ethics and also models being biased, because probably the corpus of text that people may have used on training the models were written by a specific sector of the population, and it's not representative of everyone. So that's one thing we have to have in mind. Okay, so let me talk about in the pre-training stage. So you take millions of words and then try to predict the model, and then you're just simply training your basic model. And for example, the type of data that was used to train the Llama model from Meta, they use in the first Llama 2, Llama 1 version, they use 5 terabytes of data, and they used what is called the Common Crawl, which has 12 years of web crawling. And then there is a Clean Commons Crawl C4 corpus, which is a more well, clean text. Also, they have used books, and we have the Project Gutenberg, which is public domain, all the books that have no longer the copyright, and they are free, public source. And also there's a part of books that have been pirated. So there's about 200,000 pirated books that were used for training the models. Of course, some authors and some artists are starting to sue the companies because probably they have used their work without their authorization. But in general, none of the companies disclose how they train their models. So, and this is how the data set is distributed. So taking from common crawls about 3.3 terabytes, the clean common crawls 783 gigabytes. And they use GitHub, they use Wikipedia, they use books, they use archive, and they use a lot of open public websites to extract information and train their models. And then when they're training the model, there is a process called tokenization. So tokenization is you have an input text, and then every word or every token is classified. So you have D will be the first token, and then space GPT will be a second token. Probably G and PT are different tokens, space family, space of, space models. And then once you have the tokens, then you start assigning integers. And these integers are just the index into a vector database. So every text is converted into a database, vector database, um, um, based on numbers. And then you will see probably, well, yeah, you will see probably words repeating. So for example, we have of here, of models, and we have of characters here. So of will be the fourth word, so 1641, and probably there is a 1641 further down, not sure. Anyway, that's a word, that's the way they are using the tokenization. And so in average, one token will be about 3/4 of a word. Yeah, so the GP3 model compared with the Llama 2 model, GP3 they had a 50,257 vocabulary size, and there was a context length of 2 bytes, 2 kilobytes, and GPT-3 used 175 billion parameters, and they trained on 300 bytes tokens, while the Llama had a smaller vocabulary size. They had the same context length. They had 65 billion parameters, and they trained on from 1 to 1.4 tokens. And then you will see that they have different versions of the model. So they have the small model, the medium model, the large model, extra large, etc. And this is what more or less were the resources to train GPT. In this case, they use about from 1,000 to 10,000 B100 GPUs from NVIDIA. And it took about 1 month of training, and the cost was about from 1 to 10 million per training. Llama 2, the first Llama 2 took about 2,048 A100 GPUs from NVIDIA, took 21 days of training, and cost about 5 million. And Meta has just released the Llama 3 version, and the training cost was about $100 million. They used 24,000 GPUs from NVIDIA, and they had 128,000 vocabulary size, and they train on, this will be 8 kilobytes of tokens. So it's not something that you can do on a weekly basis or a monthly basis, because the cost is, well, only the large companies, maybe Meta, Microsoft, or Google, OpenAI can do them, but it's nothing that you can do it at home. The pre-training, this is how, for example, you have a text here. So here's an example of document 1 showing some tokens. And this is the first row of the text, and the first row of the text is now tokenized here. So you can see, for example, the first row and the third row, the second word is the word is. So the word is tokenized with a number 318. That's the vector database location. And you have this end of text clearly marked here. And then, for example, row 4 has the numbers 1, 2, 3, 4, 5. So you have 1, 2, 3, etc. So comma is just the representation. The 11 is just the representation of the comma, and 16 is the representation of number 1. And 4,342 is the representation of the word here. Okay. So there's trying, once you have the initial input, then you're looking at the output from the model, and you're qualifying the output and see if they can predict what will be the next word. And this is more or less the image of the transformer or neural network that is used for training the large language model. This is an example, for example, when you're trying to train the model using data from Shakespeare. So this is a dialogue from one of the Shakespeare works, and so you take this as input, and then this is the first output of the neural network. Of course, it's just garbage, and then they keep iterating. They keep iterating 250 times, 500 iterations, 5,000 iterations, and after 30,000 iterations, more or less, the model is producing something in the style of Shakespeare, but the model has no way of predicting what it's saying. So it's just like a parrot trying to replicate words, but it doesn't know what's the meaning of, or the last thing we can do is see if this text has any sense or any meaning to us. But the model is just trying to replicate or mimic what a text that it was trained on initially. So that's how, and this output is maybe not the only one. You can ask for several outputs. This is the visualization of how the neural network and different parts of the large language model work. They have you have the inputs, and then you have all these different encoding and steps in order to produce some output. And there's this visualization of the large language model you can explore later. But this is how, for example, you give a phrase to the model will try to tokenize it, and also at some point it needs to start joining words and their neighbors. For example, didn't, it's just here it's three things or three tokens, but it's a single word and has a meaning. And then so didn't at some point needs to be just a single word, and so the animal didn't, and then you start as you progress in the iterations, you start connecting words together, and then these words are connected through a mechanism called attention in order to try to join the words to create a phrase that makes sense. So for example, on GPT-3 that has 96 layers, and the word vectors is 12,288 dimensions. So this is the first input. John wants his bank to cash the, and then the transformer takes the input and is trying to detect the parts of the phrase. So for example, at some point has detected that once it's a verb, and cash has the meaning of a verb, not an object. And then as it progresses, the next thing is this word his. It means that belongs to John, and also bank has the meaning of a financial institution and not the river bank, for example. And then after many iterations, at some point, John is just the main character, male, and is married to Cheryl, cousin of Donald, who from Minnesota, currently in Boise, trying to find his missing wallet. So the transform is trying to make sense with this attention mechanism of a phrase and the parts of a phrase. Okay, and then we have the next one of the stages, reward modeling. So you need to validate what the model is saying. And well, I'm just going to go fast here. So it's just different process and trying to, if the model comes with a word that makes sense in the phrase, then it gets a reward. And if it doesn't make any sense, well, it doesn't get any response. And the last stage is just reinforcement learning, and it continues doing just giving positive rewards or negative rewards. Um, so so that's how you continue training the model. Okay, so these are some performance of GPT-3. For example, if the model is giving exams or tests, for example, LSAT or GRE, and this is how GPT 3.5 in blue was the outcome, how many answers were correct. And GPT-4, there's a GPT-4 with no vision and a GPT-4 with vision. And so this is the performance of GPT-4. For example, you have read in the news that some chatbot GPT passed some bar exam, and this is the way they were performed. And also, you need to train a model in order to understand the context and the meanings of all the different fields. For example, this is for legal issues, and this is for math, and this is for biology, this is for writing, this is for art history, etc. So you can focus the training of the models after they are pre-trained, and then you can go to the next stage, which is fine-tuning in order to create the models. Okay. Okay, some remarks about large language models. So base models do not answer questions. They will try to, once you ask a question or you give a prompt, then it will try to find out in what context you're asking the prompt, and it will try to respond with some text in that context. So whatever you say, they will just try to complete some document they saw in the internet. And also you can trick the model into performing tasks. For example, when they launch these models, there's always people trying to have like poisoning the model, or trying to, for example, ask the model what's the best way of committing suicide. So these type of questions should be banned from those models to answer. How can I create a bomb? So they put some guardrails to the models in order that they avoid answering some specific questions of negative character. The models may be biased, of course. For example, if you are creating an image, let's say, create an image of a group of scientists working in the lab, and the image that creates may be just composed of only male scientists. So you have to ask the model explicitly to include women in the image, so the image can be more balanced. They may fabricate information. For example, you're doing some research and you ask the model for some guidance about some topic, and also you ask the model to provide some references. These references, because some of the models are not, when they were trained, were not connected to the internet, like GPT 3.5, and then like newer models like GPT-4 and Gemini and Claude from Anthropic, and Gemini from Google, they are connected to the internet, so they can go and look for some references, and you can also ask the model to give factual reference, so it's not hallucinating, because it may give you a reference, then you go to the journal and you find out that the paper is not there. Maybe the title of the journal is correct. The page and the volume may be incorrect, and also just simply not being there. They may have some reasoning errors, so you have to. There's several ways of prompting the models in order to the models arrive to a correct decision or answer. Yes, I talk about the cutoff when they were training, so they only know up until the date they were trained, and also some models are susceptible to this prompt injection or jailbreak attacks. So you can try to tune one model into different topics and like, let's say you want to train a model to show you how to produce, for example, some poisons, etc. So they will try to avoid those type of models. Okay. You can read more in these references, and then I'll just go back and try to finish. Go to the data science lab. Great. Go to the data lab GitHub, and then we're in the classical machine learning, and we were talking about large language models. Okay. So basically this has everything I was talking about, has more information, the date of the different large language models, and if you are curious enough, you can try to visualize the architecture of these models. So we have here the Nano GPT and the GPT small, and then you can follow the process step by step. What the model is doing, and this is for example, you just go to the first step. So you have the phrase, the input, and then you can just you will just take the tokens, and then the tokens will send to the input, and then the input is tokenized, and then they get some position in the vector database, and then just follow. And I mean, it has so many parts and has so many processes, how the model is working. So that's why the training requires so many GPUs and so many hours of training, because all the processes just to get the output from one input is enormous. And this is only for the Nano GPT. If you can go to the GPT-4 or GPT-3, I'm sorry, and you will see that things are more complex for the GP2 small. Okay, so this is a good reference just to follow what is the structure of the of the large language models. And you have the same information I gave in the presentation here, and you have more reference. Okay, so that is more or less an overview of what are large language models. If you have any questions, please, I'm here to answer. And if not, I will just thank you for connecting and following this workshop. And in name of the Data Lab, we are thankful that you have been connected, and we hope that you have learned, or at least start inquiring more about what we have talked during our meetings. And of course, all our meetings we have some notes, and we have the afterwards we put all the recording in our YouTube channel so you can replay and revisit all the materials. So thank you for connecting, and hopefully we'll see you next semester.